Hey there everybody, it's the Laser Wizard, and today we got something very cool to test out, and it's this rotary axis that FoxAlien just sent me. Just came out, and it honestly looks very cool, very nice. I played around with it already. I haven't used it yet, but I've moved the rollers around, I've played with the belt tensions, and it's all very well put together. So we're gonna see if we can get this thing hooked up. And I've got a nice round wooden dowel here. It's probably going to be my first guinea pig, and we'll see if we can get something lasered on here and how that process will go. So stick around. In order to use the rotary axis, we're going to have to unplug both Y stepper motors. Just unplug them, this one and this one. And the Y-axis is not going to move anymore. Instead, the roller axis is going to serve as the Y-axis. The X-axis stays. So all we're going to need to do is manually set the Y position so it's directly above our material, and then the rollers will do the rest. So next step is going to be to hook up this wire up to this stepper motor back here, and for that you may want to kind of fish this one through a little bit more just so that it can reach the stepper motor. So I'll see how I can do that right now. So ideally I'd like to use the Y2 stepper cable back there, but it's not quite long enough, and that is because there's quite a bit of slack in it back here. So first step we're going to do is fish this cable through the Y-axis drag chain as much as we can. That way we've got as much length that we can pull through the X-axis gantry. So I'll do that next. Okay, that's about as much as I can get. Oh, a couple more inches, there we go. Now we can go over this side. Hopefully we get enough length. Okay, that is perfect. Alright, and we're plugged in. And I think that's plenty. Okay, I've turned on the controller, and I'm just doing a quick preliminary check just to make sure things are moving the way I expect them to, and there are the rollers. And I'm not sure if the direction is correct just yet, but we'll see once we try to engrave something. We may need to flip some cables around or change another setting. But the next step that we're going to have to do now is that because the diameter of these rollers is bigger than the diameter of these pulleys, it's no longer 80 steps per millimeter. It's, according to the manual, it is 39.177 steps per millimeter, and we'll see how accurate that is. I think that is pretty accurate. There are a few ways that you can change this step per millimeter setting. I personally like to use laser Gerbil. It has a very nice settings menu. If you go to Gerbil and then Gerbil configuration, it gives you a whole list of all the Gerbil configuration settings, as well as descriptions of what each one is, and it's by far the best thing you can do. So right here, $101, your Y-axis travel resolution, we're going to change that to 39.177. And we're we're gonna click right, close it, and good practice here is right on the console you can type in $sign and hit enter, and you'll get all your current settings on your controller. Best way to get acquainted with your settings, also easy way to change them. So there we go, it took 39.117, and I believe that completes the total physical setup of the machine. Next we're gonna measure the diameter of our dowel, because we're gonna need to know what its circumference is. My dowel here is about 25 point, we'll say 25.5 millimeters. It's not perfectly round, but we'll say 25.5 millimeters. So it's going to be this times pi is going to be our circumference, and that circumference we're going to use to set the Y dimension of our image. That way it can go fully around the dowel, and we'll see how well that all lines up. So in order to get this dowel to be turned reliably on these rollers, we're going to have to do two things. We're going to have to remove this holder right here. This is for if you've got conical shaped pieces that you want to engrave. We'll try and use this thing later. And then the other thing we're going to have to do is bring these rollers together, because the gap between them is bigger than this dowel. The rotary axis comes with two tools. It's all you need to adjust, pretty much everything you need to adjust on here. And first thing we're going to do is loosen up the belt tension. And I like to actually fully remove this, because sometimes you have to move this into a completely different location. You can take the belt off, and we're going to have to bring these rollers closer together. I'm also going to remove this because this is probably going to get in the way, and we're probably not going to use that for our long dowel. This is the end stop to help you locate each piece if you're doing a whole batch order. And then you can butt up all your parts right up to it so that they're located in the same position each time. I've also noticed I did a little preliminary rolling of a tapered cup, and that cup tends to travel downwards until it hits the stop. So for tapered things, you definitely need to have this in. We're gonna take it off for now since we're doing a very long dowel, and that's probably just gonna get in the way of it. So we're gonna put that off to the side. And next thing I'm gonna do is I'm gonna take this off, since we're not gonna use this right now. And that could just be flipped back. It doesn't need to be fully taken off. We're gonna need to loosen at least one of these rollers. And for whatever you're going to be setting up, there's definitely going to be a few configurations that you can set this up to that might work. Some might work better than others. Manual always shows this roller always being the frontmost position. So we're going to try that, and we're just going to move this up to the closest position here. And the dowel should hopefully As long as they're both spinning, it should be good. Okay, let's see if we can get the belt tensioned. First, let me tighten these down. So for this belt, you're gonna have to find where the sweet spot for that idler pulley is gonna be. And it might be like right there. See, if we put it here, then the belt, the teeth would be rubbing on itself. So you have to kind of position this tensioner somewhere else. Alright, so that is too loose. So as you can see, it's skipping teeth. So maybe if we put it here. So now it's a little too tight. This is kind of firm. So there's actually one more adjustment that we can make. This idler here also slides and adjusts. So I'll relieve some of the pressure here so that I can hook this one up a little bit better. Okay, I think I see the issue here. This pulley here is rubbing on this bolt head right there. So we're gonna have to move it back away from it a little bit. And this pulley down here is getting caught. So we'll have to see what's going on here. Okay, that's much better. There's also a little bit of vertical movement that this pulley can go through. So you just got to make sure that it's not rubbing on any of these bolts. Okay, now we're too loose. Okay, I think we finally got it. Just like this. So you definitely want to get a feel for it. You'll know whether it's too tight or not, depending on how much it's binding. And for me right now, it's moving pretty smooth. Let's see if this dowel sits on top. It seems to be pretty consistent. Okay, So let's reconnect it and see what kind of lasering we can do. So for this test, I'm going to be using the 15-watt fixed focus laser module, and it's got a focal length of 18 millimeters. And I got Sean's manual Z-axis adjustment, which makes this very easy to adjust. And I use this ruler. I laser engraved and cut this ruler, and we're going to set it to 18 millimeters. Okay, right there on the money. So I've created this image here. It is 80 by 80 millimeters because 25.5 millimeter diameter times pi just so happens to come out to be almost exactly 80 millimeters. The length this way really doesn't matter, but this matters to a certain degree. I'm going to try and see if I can get them to touch. We'll see how that goes. Now that I notice it's probably not going to line up properly because we got a black line or a dark one coming here, but it ends on a light one up there. But that's fine. My mistake. So we're going to do one bit dithering, horizontal scanning, 10 lines per millimeter. And for the settings here, I'm going to do 3000. S-max on this controller is 1000. Full power. And the size here is, I think it's wrong. It should be 80 by 80. But actually, I think I'm going to have to run it slightly lower power. Let's try it at 70%. And not constant power, but dynamic power control. Okay, let's create it. And there it is. And I'm going to flip the machine on, and I'm going to do this operation right here, which outlines, the area. I'm going to see if it makes a full revolution back and forth. So off camera, I tried a framing operation, and I accidentally had my focus S value set a little too high, so it actually drew a square, but it looks like it drew it all the way around, so we'll see. Actually, yeah, let me take it out. Look, it went all the way around, and the two lines, they lined up perfectly, because it drew a line, went all the way around, and it drew a line back and came back, so that's absolutely perfect there. So I'm going to change this S value. Yeah, I had it set to 40%. I'm going to change that to 5%. Okay, well, I think we're focused. I'm going to turn on the Air Assist. It says it's going to be a 20-minute long engraving. So hopefully it comes out looking good. Wow, now that is pretty awesome. My very first attempt, and it lined up very well. My Only issue is that it goes from a dark to a light one. But check it out. It actually does what it's supposed to. So unfortunately I got these lines in here from when I ran the original framing operation, and I had it set to S400 for the focusing mode. But this thing looks great. I also should have used maybe a little bit of lower power, but it's got some pretty nice depth to it. This is a 1-inch diameter dowel. I measured it at about 25.5 millimeters. And you never have to change the step value no matter what diameter you use, because it's all about the surface velocity here. You just have to make sure you know your circumference, so you set that distance accordingly. And I got it down pretty good. So let's see what else maybe we can carve. Okay, I have altered the file so that these weaves over here line up, and I've also thrown in my own logo here. And I just noticed, thankfully, Laser Gerbil has pass-through mode now. So I processed it through Imager online, and hopefully this thing will come out looking pretty nice. We'll see. I'm very happy how this came out. It's just a shame that I've got these lines in here from when I did the tracing. So I'm just going to run it on the other end. It's going to be my second test run, and hopefully that comes out looking pretty nice. Just gotta stick this down in here, and it's about 80 centimeters from the end. I'm just eyeballing it here. I think that'll do. Okay, I've changed the power down to 45%, and we are gonna run it. Let me turn on the air compressor first. Well, I think my second try here came out much better than my first try. There we go. And these weaves are seamless. Text came out very nice and crisp. This is a pine dowel, so it's got a lot of these grains in here, and they kind of show up through the engraving. I don't usually engrave onto pine, but this was just the dowel I had. And yeah, that junction point was right here, right before the text starts. So you can just barely tell. That's probably just something in my file that's messed up. But I hope this has been a big help for y'all and an encouragement. If you guys want to get into rotational engraving and cutting, then this is a great add-on. Very fun and opens up a whole bunch of new doors. And doesn't take much to set it up. And don't have to change many settings. And if you want to get one for yourself, make sure you use my link down at the bottom. That'll help me out quite a bit. And hopefully I'll be making more videos very soon. Take care and good luck.